Now that you have your data, it is time to analyze that data. For this part of the activity, we will be using a statistical test to compare the observed number of individuals with each genotype to the expected number of individuals with each genotype if the population were equilibrium. The statistical test that we will use is called a chi-square test. Now, a chi-square test tells us or allows us to compare observed values to expected values to determine whether these values are significantly different from one another. Similar to a t-test, a chi-square test will give you a p-value. Now remember, the p-value tells us how likely it is that your results were caused by random chance alone. For example, a p-value of 0.01 would mean that there is a 1% chance that our results were caused by just random chance alone. So a low p-value, such as a p-value less than 0.05, means that any difference seen between your observed and expected values are probably not due to random chance alone. This would mean that your results are significantly different from one another, statistically significantly different. So, if your observed population is significantly different from the population you calculated to be at equilibrium, that means the observed population is likely not at equilibrium, right? If a population is not at equilibrium, the population is evolving. So, a low p-value, such as less than 0.05, would mean that the observed population is likely evolving. Framing this within our hypotheses, a p-value of less than 0.05 would allow you to reject the null hypothesis, which would be that the population is not changing over time. The population is not evolving. Rejecting the null hypothesis means that the alternative hypothesis of the population is evolving is supported. On the other hand, a high p-value, one that is greater than 0.05, means that the difference between your observed and expected values are probably just due to the influence of random chance, and the population is not evolving, right? A high p-value would not allow you to reject the null hypothesis, meaning the null hypothesis of the population is not evolving is supported. So now it is time for you to run a chi-square test on your data. To do this, you're going to complete the chi-square test procedure as outlined on Canvas. And this starts with you entering your data for the expected and observed number of individuals with each genotype into Excel, using the format that's provided on Canvas. Remember that your observed values are from the actual observed population, and your expected values are the genotypic frequencies that you calculated from the Hardy-Weinberg equations. After, in a blank square in Excel, use the Excel formula you see written on the screen to produce your p-value. Once you have your p-value from this formula, you're going to go ahead and write it down and then interpret what it means.